So we need to find a linear separator from this transformed dataset which has 3 dimensions. Only x4 has different label. Hence, x4 should be in the different side of the separator plane with the others. We can imagine the 3-dimensional space and 5 points are existing. So at here we need some extent of spatial awareness ability. So let's see the drawn graph. So we have 3 axes and we have x1, x2, x3 which are gathered at the below, and x4 in the middle and x5 at the top. So this is 0, 0, 0 and 0, 0.25 and 0.5 and 0.25, 0, 0.5, and x4 is 1, 1, 2 and x5 is 4, 4, 4. So now let's close your eye and create this space in your brain. So there are gathered x1 and x2, x3 in the below, and x4 in the middle, and x5 at the top. So we want to put the separated plane to make x4, which is class 1, being above the plane, and x1, x2, x4, which are class -1, being below the plane. So can you imagine this spatial situation? So now we know how the linear separator would be in the 3-dimensional space. So we have to give the proper coefficient, which is the W and B for the separator equation. So at here, we should use the trial and error method as we've done in the assignment 7 neural network to set the proper bias. So if we put the points from x1 to x5 to this equation, h of x, w1 times x1 plus w2 times x2 plus w3 times x3 plus bias. So x1 and x2, x3 means that each component of 3-dimension vector of x, not the separated sample, individual sample. So did you get the point? So if we put this data, the points into this equation, we can get 5 equations. So here only x4, so only equation 4 has different sign. So let's make this equation for less than 0 and the others greater than 0 by adjusting W1 and W2 and W3 and B. So how can we do? At this point, we can pay attention equation 4 and equation 5 because these two has larger coefficient than equation 1, 2, 3, right? So here 1, 1, 2, and here 4, 4, 4, here 0.25, 0.5, and here there is only B. So, so the coefficient, so these coefficients are larger than the others, but equation 4 is negative, but equation 5 is positive. So we can think about which W makes this situation. I would say W3. So we can assume W3 because because the coefficient of W3 is 2 times greater than W1 and W2 at the equation 4. So we can think that, W3 could be enough large negative value to cancel out W1 and W2, which could be positive values. So if if W3 is negative and W1 and W2 is positive, this W3 can cancel out these positive values and makes this entire equation less than 0, because these coefficients of W3 is greater than W1, W2. But equation 5, the coefficients are the same, so it couldn't be cancelled out and it can be remained as positive. So did you get my point? So let's assume a value for W3. So I would assume W1 is 1 and W2 is also 1 and W3 is minus 1.5 to cancel out W1, W2 at equation 4, and B is something 0.5. So if we assign these values for every equation, let's try it. And W1 is 1 and W2 is 1 and W3 is minus 1.5, so minus 3, and B is 0.5, so it is negative, right? 2 minus 3 is minus 1 and minus 1 plus 0.5 is minus 0.5. So equation 4 is satisfied. And equation 5 is 4 plus 4 minus 6 plus 0.5 is 2 plus 0.5 is 2.5. So this is greater than 0. So equation 4 R 5 are satisfied. And equation 1 is just B. So B is 0.5. So equation 1 is also satisfied. And equation 2 is 1 and minus 1.5. So it is 0.25 plus minus 0.75 plus 0.5, which is equal 0. So which means it is just exactly on the separator, on the separator plane. So so if we treat the point exactly on the plane as minus 1, as, so if we classify the points on the plane as minus 1, so the class minus 1, like, we can do it like this. So we can use this weight and bias, but we can just increase bias to 0.6 and it will be 0.1, and the others are also satisfied even if we increase just the bias. So equation 2 is also satisfied. And equation 3, let's check it. 0.25 minus, this is minus 0.75, right? plus 0.5 or 0.6 is also 0.1. So so it is satisfied. So it would be better to set b to 0.6 than 0.5, because if we set b as 0.5, 2 points are on the plane, which is the separator. So to make it more separable, we can just increase the bias a little bit. So now it's finished. So we can select W1 is 1, W2 is 1, W3 is minus 1.5, and bias is 0.6. So it is finished after just one assignment, right? So so it's quite cumbersome to manually find proper values, but it's solvable by trying several values and adjust it. So to solve this kind of question in the exam, we need to practice it and repeat several times. So I hope you guys understand it, and thank you for watching it, and bye bye.